welcome to the last talk of the of the conference. So my name is Denis Plotnikov. I'm a software developer at Virtuozzo, and I'm working on kernel development in different places. So why am I here? It's because background snapshots, obviously. And some day ago, my boss was hacking around kernel, and somebody from user support called him and said, "Hey, Dan, your software works badly." And he replied, "Why?" And you know, we have a customer. That customer makes a snapshot of the VM every time, every single day, and it took him 2 minutes to do that. And then said, "And what?" And they replied that because it's bad, because it's a VM working on the production. And it cost him a lot to leave. Oh, here it is. And it cost the customer a lot to have 2 minutes VM downtime every time. And my boss said, "Okay, I will do something about that." And then I was hacking around the kernel, doing something, and then he called me and said, "Hey, Dan, you know what?" I said, "What?" "And you need to do something with the snapshot." And I was like, "Oh, okay, sure, I'll do something with snapshot." So, but I was like, "What? What is the snapshot?" So, and here is agenda, but this is not interesting. And that's what the snapshot is. I'm talking about the VM snapshot, and it turns out it consists of 2 parts. The disk snapshot, somehow state of the disk, data of the disk saved somewhere, and other virtual machine devices state also saved somewhere. And it turns out that to make a disk snapshot it is already solved problem. So if we are talking about QCOL2, it's basically very fast, because all you need to do is to copy a mapping table which maps guest offsets to host offsets. And this table is not that big, and you just can copy that, and you're good to go with this snapshot. With virtual machine devices states, it is also kind of solved problem, because on migration, you use a migration stream to save all your devices states to some place. So it's also good. But it turned out that to take that snapshot, you need to stop the VM and save all the states into some destination, let's say, save file with the VM stop. Then I went into VM device states and start investigating where actually time consumes. And it turned out that the biggest part of a VM device state is memory. It usually consists of hundreds megabytes or even gigabytes, when the other VM state is around 10 megabyte overall. So then I started thinking that we need to save that memory somehow in the background, kind of asynchronously, to actually pretend that VM working okay, but saving meanwhile the memory at some place. So I decided to start doing something about that, and encounter another thing, that snapshot has 2 types. There are internal snapshots and external snapshots. External snapshot, it's fairly easy. You just need to give a destination to your thread to save it somewhere. But internal snapshot is tricky, because when you're thinking about asynchronous write in your memory, you need to calculate what size of memory. So internal snapshots are saved inside disk image. So to write something in that image asynchronously, you need to pre-allocate the space in that image. And to pre-allocate that space, you should calculate everything. So you are not really use stream semantics, which migration implements. So I decided to not think about internal snapshot and go with the external snapshots. So here is the definition, so-called definition of background snapshot. So it allows you to save a virtual machine with minimal downtime. By saying minimal, I mean that we actually stop the VM and grab all the states which should be freezed, which should be immutable at the time. And then we doing some hacks to write the mem asynchronously. So here is the 3 bricks. We use existing virtual machine migration code to save the VM state, and we just need some modifications there. And we use existing implementation of snapshot for the disks, especially for cookout 2. And the hardest part is to actually write memory synchronously. So there are 2 ways to do that. You basically, what you need to do, you need to somehow seal your memory and write it chunk by chunk. To do that, you just protect your memory from writing. And here is 2 ways you can actually intercept the writings from the peers. First one is to use a segmentation fault handler, which happens if you access memory which shouldn't be accessed really. But it turns out that we can't use that because key EMU is such a good thing that sometimes it shares memory with different processes, and if another process access your memory, you can't really intercept it with a zigzag handler in your process, so it will break your memory. You can't do that. Then we decided to use user fault FD. Actually, migration already used user fault FD for post-copy migration, but it turned out that user fault FD doesn't have write protected mode tracking yet. But I know that some person work really hard to make it happen soon. So we totally rely on that user fault of that. Then here is how our background snapshot is seen for user, and what do you need to do to use it. Actually, you just need to make a migration with corresponding capability set. You save capability, pause your VM, make disk snapshot, which is fast, make then start migration thread. Migration thread collect all the device states except memory. It saves it in the destination, and then it start writing the memory. And while it's writing the memory, vCPUs is already running. They are not released anymore. So what do I achieve? This is numbers for just an idling VM having 2 gigabytes of RAM. Of course, it is a kind of not realistic scenario, but and when an important thing, when you're using background snapshot, you will experience some slowing down of your virtual machine. This is because when vCPU encounter a page that should be written, it stops, puts the page in the priority queue. This page from the priority queue is taken before all other memory pages, which is written sequentially. writes it to the destination and release the CPU. So you will have you will have experience freezing at that time, but it is better than the downtime for quite a big amount of time. And this is where we are now. We have draft implementation, and where the majority of functionality is ready and waiting for user fault if they were write protected mode linked into the mainstream. So that's it. Please ask questions. Sure.
So I haven't been following these patches too closely. How far along is the write protected patches for the Linux kernel? Do you know?
I don't know. I don't know for sure. But oh, sorry. I don't know. I don't know. I don't know for sure. But I believe Peter is working on them. And here also interested in getting those patches.
So do you have like a work in progress patches that you're testing this on top of?
We're about to do that.
Okay.
Any questions related to being in Edinburgh, maybe? Something. Okay then. Thank you very much.